Welcome back to another video. Today we are going to prove theorem 2.4.5, which states that if a and b are integers such that d equal to the greatest common divisor of a and b, then the greatest common divisor of a over d and b over d equals 1. Okay, let's prove this. So what we have right here is like we can divide by d both sides of this equation. Okay, now let's prove this one. So we have a and b integers such that d equal to the greatest common divisor of a and b, and then let's write this. Then we're gonna have d, which is the greatest common divisor of a and b, which is dA over d and dB over d. Okay, we can write this fraction because we multiply and divide by d. Then let's use this theorem 2.4.4, which is the greatest common divisor of MA and MB equal to M times the greatest common divisor of AB. Okay, let's try. Let's continue. So we're gonna have this. So what we have is we're gonna use theorem 2.4.4. So which state that for all integers, positive integer m, you will have the greatest common divisor of MA and MB equals M times the greatest common divisor of A and B. So what do we have right here? So let's write d again, which is d over dA over d times dB over d. And we're gonna have d times a over d, d times b over d. And then we factorize d out of these greatest common divisor a over d and b over d. So we're gonna have d times a over d and b over d. Okay, what can we do next? So what we have is we're gonna have the greatest common divisor of a over d and b over d, which is now, it's like we multiply both sides by 1 over d of this equation. So we're gonna have 1 over d times d times the greatest common divisor of a over d and b over d. Okay, and what is this one here? This term right here, what is it? Okay, it's going to be just, okay, let's do this. We're gonna have 1 over d times d, right? Okay, 1 over d times d. So we're gonna have 1 here. Okay, and that's it for this video.